Look up at the sun. In just 1 hour, the sunlight that strikes our planet contains enough energy to power the entire human race for an entire year. It's an almost unimaginable amount of raw power. But for most of human history, all we could do was bask in its warmth. Today, however, we can capture that light and turn it directly into the electricity powering the screen you're looking at right now. And the craziest part? It happens completely silently, with zero moving parts. Welcome to Simple Things Surprising Histories. Today, we are uncovering the hidden magic resting on millions of rooftops around the world. How exactly do solar panels turn sunlight into electricity? To understand the magic, we actually have to travel back in time to 1839. A 19-year-old French physicist named Edmond Becquerel was playing around in his father's laboratory. He dunked 2 metal plates into an acidic solution and exposed them to light. To his absolute shock, a small electric current was generated. He had just discovered what we now call the photovoltaic effect. But for decades, it was treated like a strange parlor trick. Nobody truly understood why it happened. Fast forward to 1905, when a young Albert Einstein published a paper explaining that light isn't just a wave, it's actually made of tiny, invisible packets of energy called photons. Einstein realized that when these photons crash into certain materials, they act like microscopic billiard balls, knocking electrons right out of place. This specific discovery was so groundbreaking that it won Einstein his one and only Nobel Prize. He gave us the theory, but we still needed the perfect material to make it useful. You can't just leave a piece of random metal in the sun and expect it to power your toaster. You need the right material. Enter silicon. Silicon is the second most abundant element on Earth. It's essentially the main ingredient in beach sand. But when purified, silicon becomes something very special, a semiconductor. That means it rests perfectly between being an insulator, like rubber, and a conductor, like copper. By itself, pure silicon is pretty lazy. Its electrons are locked tightly in place. But scientists figured out a brilliant trick. They dope the silicon by mixing it with tiny amounts of other elements, like phosphorus and boron. By doing this, they create 2 distinct layers of silicon. The top layer is loaded with extra electrons, giving it a negative charge. The bottom layer is missing a few electrons, giving it a positive charge. When you stack these 2 layers together, you create a permanent electric field at the border between them, like a tiny invisible force field. This is the beating heart of a solar cell. Now, let's bring back the sun. When sunlight, those tiny billiard balls of energy called photons, smashes into the solar panel, it hits the silicon with just enough force to knock the electrons loose from their atoms. Because of that invisible force field we created, those loose electrons are pushed in one specific direction. They can't go backward. Their only escape route is through a tiny metal wire attached to the panel. As these electrons race through the wire, they create an electric current. That flow of electrons is electricity. It is literally light from a star physically pushing electrons through a wire. But wait, we're not done. The electricity coming off a solar panel is called direct current, or DC. In DC, the electrons flow in a single straight line. But your home, your TV, and your refrigerator run on alternating current, or AC, where electrons rapidly switch directions back and forth. If you plugged your TV directly into a solar panel, it wouldn't work. So the electricity travels from your roof down into a device called an inverter. The inverter is the translator. It takes that raw DC electricity from the sun and seamlessly converts it into usable AC power, feeding it directly into your home's breaker box. Whatever electricity you don't use gets pushed back out into the city's power grid, often spinning your electricity meter backward. It's incredible when you really stop and think about it. The simple act of turning on a lamp in your living room could be fueled by a photon that traveled 93 million miles through the freezing vacuum of space, crashed into a piece of purified sand on your roof and quietly pushed an electron down a wire. No noise, no smoke, just the silent magic of the universe at work. If you enjoyed this journey, please hit that like button, share this video with a curious friend, and subscribe for more simple things and surprising histories. Thanks for watching, and I'll see you in the next one.